Good evening, and today we're going to look at solving two-step equations. This morning in class we looked at one-step equations just as a review because you all know how to do those. So you're already familiar with the idea that we have to figure out what this x is. So down here at the very end, when we get this solved, we'll have x alone, and we're going to have it equal to some number. So then I'm going to make you check it to see if it's correct, if this is the right number. So you're going to have to plug it back in for x. When you do that, you're going to use order of operations over here. You're going to multiply first by 7, whatever that number is, times 7. Then you're going to add 4 to it, and it should equal 25. If it doesn't, then you've got the wrong answer. Okay? So we've talked about the idea that these two sides are equal, they're balanced. And so we're trying to get this x alone, and we have to use the order of operations backwards to go backwards to figure out what the x is. So addition is the last thing we do in order of operations. So that's the first thing we're going to do here. We are going to make this number 0 so that when we add 0 to 7x, we have 7x alone. Okay, and that's the additive identity property. But we're going to have to use the additive inverse of 4 to make this value 0. Okay, so what I like to say for those of you who are not real comfortable with equations, draw a line down here because I'm going to talk about this side and this side, like two sides of a balance. Okay, and the equal sign is where the balance is. And so if I take something off of one side, it gets lighter. So I have to take it off the other side to make it equal again. We got to keep this equal. So the additive inverse of positive 4, because that's like a positive 4, is negative 4. So I'm either going to add negative 4 to this. That's the same thing as subtracting 4. We talked about that last quarter. And so I have to subtract 4 from both sides to keep it balanced. Now, over here, when I take 4 minus 4, these are additive inverses, and we know additive inverses add up to 0. So now, I'm really adding 0 to 7x. And over here, I've taken off this 4 also. So on this side, 25 minus 4 is 21. And they're still equal because I subtracted 4 from both sides to keep it balanced. So now, I add 7x to 0, and that's going to help me get 7x alone, because 7x plus 0 is 7x. That property we talked about this morning, that's called the additive identity, which means when I add 0 to any number, I get that identical number back again. Identical number. So now I know that 7x is equal to 21. So now this is like the ones we were talking about this morning. It's a one-step equation. So now I need to figure out what times what times 7 equals 21. So I'm going to do the multiplicative inverse. So if I'm multiplying by 7, I can either multiply by 1/7 or divide by 7. It means the same thing. I'm just going to do divided by 7. And I'm going to divide by 7 on the other side to keep it balanced. So now I have 7 divided by 7. And 7 divided by 7 is 1. So now I have 1 times x on the left. And that's equal to 21 divided by 7, which is 3. Well, we have x alone now because by the multiplicative identity, one times x is x alone. And x is equal to 3. And then if we go back and check it, when we check, we say 7 times x. Well, we're going to put in 3 for x, plus 4. We want to know, does that really equal 25? So we're going to do the order of operations. So multiply first, 21 plus 4. Yep, that's 25. So we say yes, we have 25 on both sides, so that checks. You need to know that these identities are important to solving equations because that's how we're getting the variable alone. So now let's look at, excuse me, Annie, and I'll introduce you to Annie in a minute, a few minutes. Okay, so now I've got my variable on the right side and I'm trying to get P alone. So this doesn't look like a two-step equation, does it? But really it is. Because remember, when we subtract, that's like adding the opposite. Okay, so we're going to change that to 12 equals 4 plus negative P. And if you guys will recall, when we were raising numbers, or raising variables to exponents, if we have a parenthesis around that, remember if we squared it, then that means that's a negative P times a negative P. Okay, well in this situation, there's no exponent. I'm not trying to confuse you, but what I want you to see there is that negative P means negative 1 times P plus 4 equals 12. That's what that really means. So there is a number multiplied by P, and there's something added. So we have to get this P alone, and so we have to look at this number here. It's addition. We're adding 4 to negative 1P. So we have to get rid of that, and it's a positive 4. You look up here, and there's no sign, so it means it's positive. So the additive inverse of positive 4 is negative 4. So just like I subtracted or added negative 4 here, because that's added on to this term that has the x in it, well, I have to add negative 4, subtract 4 here, because it's added to this term that has a P in it. So on both sides, I'm going to subtract 4. So 4 minus 4, or 4 plus negative 4, is 0. And then 0 plus negative 1P, and over here I have 8. 12 minus 4 is 8. So now here, 0 plus negative 1P is just negative 1P when I add those together. That's the additive identity, just like here. And then on this side, I have it equal to 8. Now, I got to get P alone. It's negative P, or negative 1 times P. So I can use the multiplicative identity, and I can divide negative 1 by negative 1, it's multiplicative inverse, and divide 8 by negative 1. And I end up with negative 1 divided by negative 1 is positive 1. And that's really positive 1P equals 8 divided by negative 1 is negative 8. And positive 1 times P is just P equals negative 8. So when we got here and had negative 1P equals 8, well, then its opposite, negative 8, will equal positive 1P. But here's how to show it mathematically. Divide by negative 1, just like over here we divided by 7, and do that on both sides, and we're left with negative 8. And if we check it, we're going to have, does 12 equal 4 minus, and I can go ahead and put minus, negative 8. So 4 minus negative 8, well that's 4 plus positive 8, so that's like 4 plus 8. And 4 plus 8 is 12. So I have 12 on both sides, so it checks. So when you do these for your assignment, I do want you to check them. And I know it seems a little redundant to show all this work, but I want you to show all this work for a while until you've convinced me that you understand why you're doing all this. Then I won't make you do that anymore. Okay, so this was example 1 that I'm erasing. And I forgot to put it up here, but this was example 2, and those should be copied on your notes. If you forgot to copy them on your notes, you're going to want to stop and rewind the video and do it again so you can copy all this down on your notes. Because I want you to have down the additive identity and multiplicative identity. I want you to write those words in so you get used to that. This is important for the end of the video, so I'm going to lay it to the side right now. Okay, so now we're on example number 3. In example number 3, is 25 equals x over 3, or that's x divided by 3 minus 14. Okay, so we're going to look at this one again. We got to get this x alone. And I'm going to go ahead and draw a line here so we can see our two sides. And we've got minus 14. Now it looks like negative 14. Well, it is the same thing as plus negative 14, and I would go ahead and write it like that. So I want to get the x alone, so I look at my addition or subtraction first, and the additive inverse of negative 14 is positive 14. And those will add up to 0, so I got to add 14 on this side as well. So when I do that, I get 0 plus x over 3. And over here I get 25 plus 14 is 39. And then x over 3 plus 0, the additive identity, I have x over 3 alone now. And I have 39 still on the left. And now I need to get the x alone. And the multiplicative inverse of, that's like dividing by 3. So the multiplicative inverse would be like multiplying by 3 over 1. And over here I don't need to put it over 1, I'll just put times 3, that's the same thing. Over here, this 3 in the denominator divides with this 3 in the numerator, and that's like 1 over 1 or 1. So x times 1 is x. X divided by 1 times 1 is 1. So x divided by 1 is just x alone. That's the multiplicative identity, even though it's division. You get the identical number back again. Okay, and then over here we get 3 times 39. So I'm going to do the distributive property here. 3 times 30 is 90. 3 times 7 is 27. 90 and 27 is 117. X divided by 1 is x alone. So x is equal to 117. So when I check it, if I take 117 divided by 3 and then subtract 14, will I get 25? Well, 117 divided by 3